Okay, so on these type of problems, the empirical formula is the simplest ratio. So in this one, we laid it out in steps. If they were a percent, then we change the percent sign to a gram. That was step one. Well, these are already in grams, so we don't have to do that step. Second step is to change grams to moles. So for each one of these, we know how many grams are in a mole. For chromium, the number of grams in a mole for chromium is 51.996. We can just make that 52.00. That's equal to 1 mole of chromium. We'll do that calculation here in a second. We also have 2.37 grams of oxygen. We have that one memorized, 16 grams of oxygen to 1 mole of oxygen. We do the calculation for both of those. Really easy calculations. 5.13 by the 52. Some students are not taking these out as far as they need to, so try to take them out at least 3 or 4 digits. It's not going to hurt anything. Don't worry about significant digits on this. It just gives you more digits to compare, and that's good. So some of you on your assignment didn't do that, and you came up with goofy ratios. All right, so this is 0.1481. Okay, those are moles for their respective elements. Okay, and we sit back and we look at this and realize we got to get these to whole numbers, so we divide by the smallest number. That's step 3. If you're following your steps, if you like doing that. A lot of students forget this step, and they get confused at this point. So we know this is going to be 1 mole of chromium. All right, so then we take the 0.1481 divided by 0.09865. You get 1.5. So don't round that to 2. Some of you guys are rounding that to 2. You have to take these and look at them both. And what do I need to multiply them both by to get a whole number? And that would be 2 for both of them. Make sure you multiply both of them by whatever that number you need to get rid of the decimal. And so on this one, our final answer would be Cr2O3. And that would be our compound. All right? So like the other videos, we're going to give you another example to do. It's going to be with tin and fluorine. So go ahead and do that video. Go ahead and stop the video. Go ahead and do it. Now these are in percents. So you're going to have to do the first one on your step and change percents to grams, and then go grams to moles, and then divide by the smallest number of moles. Okay, so what we'll do is we'll take the 61 grams of tin and change it to moles of tin. So what you should have done is find the molar mass of tin. The molar mass of tin is 118.71 to 1 mole. And then 39 grams of fluorine, we're going to go ahead and divide it by its molar mass, which is 18.998, so we're just going to make that 19 is equal to 1 mole. We're going to get our mole values. And we get values of point. Remember, take this out further. 5139, we're going to go ahead and say, and then this would be 2.053. So we're going to divide by the smallest number of moles. So this is moles of tin. This is moles of fluorine. So we divide it by itself. you get 1 mole, 10. You take this one divided by 0.513.
You have the, what's it called?
Okay, so then I go ahead and divide it 2.053 divided by 0.5139, and I get a number that's 3.994. I can make that 4 moles. So if you went ahead and did it right, then the ratio is going to be 1 to 4, and it's going to be SNF4, and that's your empirical formula. Okay? In the last video, we'll take a look at how to do a molecular formula, which is the toughest one for students to do.